Today we're talking about the midsegment of a triangle. And we've seen the midsegment of a triangle before, but we're just going to define it now. So the midsegment of a triangle is a segment, thus segment is right there in the word, that connects the midpoints. That's where you get the mid from. So we're going to draw a picture to go with that as well. Of a triangle. So find the midpoint. Let's mark that we have a midpoint. And then find another midpoint. Make sure you mark that you found the midpoint. And then connect. That is a midsegment. Maybe we'll put a little arrow here and write midpoint. Same thing. This is also a midpoint. So down here in example 2, to show that the midsegment FG is half of side D and parallel to. And that's one thing you're supposed to figure out in your activity, and I think most of you did, that this segment right here is half of this segment, and it's obviously parallel. So let's put the parallel symbol on here. Also parallel. So we're going to show that using some algebra. So first of all, we need to find where F and G are. Well, from our picture, we know that F and G are midpoints. So we're going to have to use the midpoint formula. So to find F, we are going to have to find the midpoint of EC. So we're going to average the x's, -3 and -3. Hopefully that you know the average of -3 and -3 is -3. Then we have to average the y's, 4 and -2. Let's see, that's 2 divided by 2, which is 1. Let's put that in our picture. -3, 1. Now you could have counted in this case because the graph is given. Now to find G, we need to find the midpoint of E and D, because see how G is in the middle of those two? So we're going to average -3 and 5, which is going to be 1. We're going to average 4 and 4. I hope you know that the average of 4 and 4 is 4. So now that we know the coordinates, we can find the slopes. Here's the slope formula over here if you forgot, or you could also count, but that's how we're going to find if they're parallel. We're going to know these are parallel because they're going to have the same slope. So the slope of CD, we're going to do y minus y, 4 minus -2 over 5 minus -3. So that's going to be 6 over 8, which reduces to 3/4. Now FG should have the same slope. Let's put G up here. We found that G was 1/4. So y minus y, 4 minus 1, 1 minus -3. 3 over 4. Good. So those are the same. The slopes are equal. So that means that they're parallel. CD is parallel to FG. So let's mark that on our picture. This is parallel to this. Now they want us to show that the length is half. Well, in order to show length, we have to use the distance formula. So we use the distance formula now for 5 chapters. But here it is, just in case. I'm going to do it off to the side because I like to shortcut it. So for CD, well guys, I already know that the difference in the y's is 6. We already did that. And we already know the difference in the x's is 8. So we can just do 6 squared plus 8 squared. You can fill all this in if you want, but let's just make our life a little bit easier. Alright, so that's what, 36 plus 64? 36 plus 64, which is 100. The square root of 100 is 10. So CD is 10. Now we need to find the length of FG. Well, it should be 5. If we did a good job, it should be 5. Let's check it out. I have to subtract the x's. Well, I already know that's 4. And I already know when I subtract the y's, it's 3. 4 squared plus 3 squared is 16 plus 9, which is 25, which is 5. Perfect. We knew that it was supposed to be half, and now we just proved it. FG, which is 5, CD, which is 10, is 1/2. FG is 1/2 as long as CD. So here we turn that into a theorem, the midsegment theorem. DE is parallel to AB, and DE is half of AB. So you're always looking to the parallel side. So here's an example. ST and TU are midsegments. So immediately I know that this is a midpoint, and I know this is a midpoint, and I know that this is a midpoint. Just marking my picture in case I need that. Just find PR. Well, I'm always looking to the parallel midsegment. So I know that it's double of 20. Double of 20 is 40. Because we are going to double TU. Let's look at ST. Well, ST is parallel to QR. So those are the two I'm going to look at. I'm going to keep myself focused there. Let's color that maybe to keep ourselves not confused. So TU goes with PR, because see, those are the parallels. That's where you're going to do half or double. Now we're looking at TS, and we're going to focus on the 30. Those are the two that go together. So we're going to do half of 30, half of QR. Half of 30 is 15. All right, you're going to go ahead and do these now. This is just like example 1. This is just like example 2. Pause the video, work on those, and then we're going to check your answer. So in order to show parallel, we have to find the slopes. In order to show half as long, we need to find the distance. So I'm going to do the counting method. You already saw me do all the algebra. So the slope of MN, let's see, we're going to go up 1, 2, 3, back 2. So that's 3, negative 2. That's the slope of MN. What about the slope of KJ? Going to go up 1, 2, 3, 4, 5, 6, back 1, 2, 3, 4. So that's 6, negative 4, which is the same. All right, we just showed that they're parallel. Mark that on my picture. Now I need to show that they're half. Well, let's see. MN is 3 squared plus 2 squared. And KJ is 6 squared plus 4 squared. Right? Look, I already knew these numbers. I already knew the difference in the y's and the difference in the x's. So that's 9. 9 plus 4 is 13. And down here, this is 36 plus 16. 36 plus 16. Let's check that out. It's 52. Like, well, how do I know this is double? Well, let's break this down. This is a 4 inside, which is 2 root 13. Check it out. One's root 13, the other one's 2 root 13. This one is double of that. Perfect. Down here, AB and BC are mid-segments. So here's AB. We're going to look at XZ. To find XZ, we're going to double because we're getting bigger. 28 doubled is 56. Now to find BC, let's find where BC is. We're always looking parallel. Here's BC, here's XY. Ooh, now we're going to take half. Half of 28 is 14. Because see, we're getting smaller. So we want to take half instead of doubling. All right, let's look at the next example. You know what, let's skip this example for now, and let's go to the next page. I think it's a little bit more helpful. So now we've got 3 mid-segments. This looks a lot like your activity. And we need to compare the perimeters, the small perimeter to the large perimeter. Well, let's find the sides. Before we start doing a bunch of comparisons, let's find the sides. So if this is 9, this is going to be 18. Because it's parallel and double. This is 12. This is going to be 24. All right, I'm going to get one more color for us. Now we have 15. 15 is parallel to this, so we need to double 15, which is 30. All right, so let's see, the inside perimeter is 9 plus 12 plus 15. That's a smaller triangle. 9 plus 12 plus 15. 9 plus 12 plus 15 is 36. Now let's find the larger triangle. The larger triangle is 18 plus 24 plus 30. 18 plus 24 plus 30, 72 inches. How do these two numbers compare? You notice this one is double of that. And that should make sense because we doubled every side. So we're going to double the perimeter. The perimeter of triangle MNP is double of the smaller. So now I want you to do this checkpoint just like example 4. Pause the video, and then we'll check your answer when everybody's done. So once again, I'm going to use my colors. We've got mid-segments, and we're going to compare the perimeters. Well, we already know what it should be, but I'll work it out just in case. Now we're going to go half. So we know this is 5. See how we're getting smaller? This is 7. That makes this 3.5. And if this is 11, that makes this 5.5. So the perimeter of triangle ABC, we'll say perimeter, the perimeter of triangle, what are these letters? DEF. We already know it should be half, so we really didn't even need to do that work. I see here that we've got 17, we've got 28 here in ABC, so I already know this should be 14. But let's check just to make sure. 5.5 plus 5 plus 3.5, 14. Perfect. Notice when we compare, it is half, or you could say double. The perimeter of triangle ABC is double of the perimeter of triangle DEF.